4.5 in geometry revisited. Fang Gangnos. Bag nanos. I didn't mean to offend. Problem. Okay, so we skipped 4.4 because that was a self-reading session. Okay, and I think some of the people have actually done it with us, but we don't repeat these things. So yeah, that's how it is. Originality is very important. The originality of reading someone else's book is very important.
What is that diagram?
Huh?
This diagram is scary.
Yeah, so that's not the diagram. So this is very interesting. It's a very short section, okay? It's describing a problem. The properties of mirror image can be used. So this is kind of like a substitute for 4.4. It's kind of related, right? Reflections was 4.4. The properties of mirror image can be used to derive many interesting theorems. So actually the problem that it was meant to state, let's see. What is the minimum perimeter? At this point, I just stopped caring how to spell these meter words. And not caring about it has made me more right than wrong.
Yes.
Well, actually, more importantly, it's made me more right than before. Okay. Unless, of course, I'm only reading the ones that confirm my rightness. Okay, so given an acute, finding the triangle of minimum parameter inscribed in a given acute triangle. So let triangle ABC be acute, yeah?
Yeah.
Inside triangle ABC. So I guess what that means is you have a triangle, right? And you're trying to fit another triangle inside. And the perimeter of the red triangle is meant to be as small as possible. How do you do that, right? Okay. Okay, so the properties of a mirror image can be used to derive many interesting theorems simply and in a striking fashion. We shall use these properties to solve the problem of finding the triangle of minimal perimeter inscribed in a given acute triangle. This is known as Fagnano's problem.
Yeah.
Proposed in 1775, who solved it by calculus. So calculus was around in 1775, okay?
Wow.
So when we're trying to learn advanced stuff by learning calculus, like modern stuff, yeah, calculus it's easier to discover calculus. Wait, when was Australia discovered? It's easier to discover calculus than it is to discover Australia. Or what about America? It sounds like America is not far off.
America's like 1600.
Oh, okay. Yeah, I guess at the time it was probably better off staying at home calculating than to sail the treacherous waters. Yeah. Um, okay, so for a solution, see the figure. We begin with the arbitrary acute angle triangle ABC, in which we have inscribed, okay, two triangles. Oh, two triangles. Inscribe two triangles.
Yes.
Okay, so the two triangles, I guess, in this case, this is A, B, C, yeah? Dashed and dotted look very similar. Okay, they're not parallel.
Four feet. Wait, you have to. Oh, we're doing some of
So this is P and this is Q, I guess. Okay. Okay, how are we drawing this diagram? I need to have these textures ready.
I'm so confused. What is the orthic?
Oh, I'll explain. It was covered in chapter 1.
Oh,
Uh-huh. Late to the party.
yes. Also,
No, it's okay.
only chapter
No, no. You never have to be sorry to be late to a party.
1. I'm fashionably right.
It's, okay, what happened now?
Not reflected, basically.
Yeah, so it looks like we've reflected B, yeah? That's how we got this type of diagram.
Yeah, over AC.
So we reflect B about AC, yeah?
Mm-hmm.
So we get this kind of thing going, yeah?
Yes.
Oh dear.
I
This is
hear
B. So now it's a congruent triangle, yeah?
Yeah. And you reflect
Okay.
the opposite from
Yeah, so this is the only geometric proof where the answer isn't going to end up obvious because it's the diagram is going to degenerate. Okay, so let us reflect in its sides AC, CB. So let's just keep reflecting, yeah?
Mm-hmm.
Now we inspect the diagram to see what this continued sequence of reflections has done. Okay, so let's look at the red, okay?
Whoa.
The red.
How come the dash line that seems
Okay.
amazing?
So what does this red line do?
This looks like
They're not defined to be straight, are they? No.
way.
Are they defined to be straight? Or did they just draw a straight line?
Oh, since they form triangles, so like it would be the sweet instead.
Oh, so this is between AB and AC. Now it's AB and AC, so it's kind of more like crooked, isn't it? And this is like that. And this is like that, yeah?
Oh, isn't it both the triangle just like it means it keeps like a straight line.
So orthic is the one. Oh, actually, you missed Tuesday, didn't you?
I missed everything.
Yeah, orthic is just when you have the orthocenters. Like when you have the altitudes, the base of the altitudes make the orthic triangle.
Wow.
Okay. So this is reflected to where? It should be bigger, huh? So, like that. That. And then back to here,
Yeah.
yeah? Okay, and then it goes on and on.
Yeah, it just keeps that's really beautiful.
Maybe we can go in the other direction too. Would that help?
Mm.
So we were meant to have done it at least 5 times. Mm-hmm. Do-do-do-do-do-do-do-do. Yeah, lots of reflections, huh?
Mm-hmm.
What do we notice about the reflections? Oh, it's that same theme as before, yeah? So, so the reflection, so what happens when you reflect it, right? So I'm not reading this, but I remember we did this reflections topic, right? So you see the purple line, let's call this um,
Mm.
P prime, P double prime, yeah?
Yeah.
Okay, so P prime, P double prime
Mm-hmm.
is like, okay, let's draw another. How many reflections do we need?
Ah.
I don't think we need five. I think we only need two.
Oh.
Yeah,
Mm-hmm.
right. It just
Oh,
happens
yeah,
to
because it
continue.
repeats.
So what happens is, see, if you look at this path, right, going along the reflections, yeah, that's P to P double prime to P prime to P P, right?
Mm-hmm.
Yeah, and then the last one is to P prime, yeah.
Yeah.
Does that make sense?
Yeah.
So that's the perimeter.
Oh.
Oh,
Mm. And then you have to prove that the ortho triangle gives you focal line because it's a straight
oh. This Sean says configuring continuant makes a parallelogram, which was what they were doing. Oh, okay. Oh, okay. So maybe we do need to continue some more. But at this point, right? Yeah, the shortest distance is a straight line, right?
line. Mm-hmm.
Um,
But they didn't start in the same place.
huh?
Well, the two lines don't start in the same spot, right?
Or which lines?
Like Q, Q.
Yeah.
Mm. I guess I shouldn't know. Because,
So for Q, it's that's Q, right? That's Q prime, Q double prime. This goes to Q double prime, and back to Q, right?
Q's the other one. That one's Q prime.
Yeah.
Yeah. Uh-huh.
Okay. So I can see that if you had some choices, you'd want to make these straight, right?
Mm-hmm. Oh, wait. Oh, I know. Wait.
Mm.
I think he means like from the triangles to prove it's a straight line. Like if you draw from that B to that B, right?
This
It would
B.
yeah,
Yeah.
to the second B,
Second B.
like when you flipped it,
Yeah.
that would go through Q double prime, right? Q prime.
Oh. And why is that?
Because wait.
You get to choose where it is. Oh, you're assuming it's minimal.
I'm pretty sure it has to. Like,
So it goes through the midpoint, right?
doesn't it go through? Yeah, because it's like a kite, right? Wait, no, it's not. It's like yeah, it is like a kite, right? Because AB is equal to AB, and BC is equal to BC.
AB.
AB equals to AB and BC equals BC. So
Yeah.
it's basically a kite. And kites, diagonals of kites are perpendicular. Right?
Yes.
Yeah, so that means AB perpendicular to AC, which means the point Q prime has to be at the intersection. Because if it's the orthic triangle, right, then AQ prime is an altitude.
Oh. Hold on. You're saying something insightful.
Yes, insightful.
What is this? So you have this as a kite, right? C, yeah? So it's like that, yeah?
Yeah.
And you're saying you want it to be a straight line, is that right?
Right.
Which triangle are we talking about here?
Right, so you can probably okay, maybe I can make this
I think it's onto something. I guess we could continue it that way. If we really needed to, right?
Yeah.
That's about how many they have. 5, 6. So there does seem to be some choices in which direction to reflect. But I think it's negated by which you want to continue to one that you haven't done before, right? You want to cycle in 3, so you don't want to do like A, B, A. You want to do A, B, C.
Like X you keep going on the X.
Oh. Okay. Prove what's straight.
Q, Q prime, Q prime, prime, Q prime.
You can't prove it's straight, right? Like what you're proving that if it was straight, maybe with some other condition, it would be the minimum, yeah? So this is just any PQ, right? It obviously won't be straight.
Oh, I was trying to prove like if Q, Q prime, Q prime, prime was the orthic triangle, and then
Oh, you're trying to make this the orthic triangle.
Yeah, all ABC.
Oh.
Doesn't that would work for like all the reflections.
Oh. That's good. I think we're onto something. Okay, so there's some property about orthic triangles that we need, yeah? So if you have a triangle, yeah, the orthic triangle is the one you get by drawing the altitudes. So this needs to be acute for it to work, okay? So you have the orthocenters inside, and it's this, and this is the orthic triangle, is this one. Huh? And the main result that I remember about this is that these angles are the same. Okay, so what it's saying is that the orthocenter of the big triangle is the in-center of the small triangle, of the orthic triangle. Yeah, because that's what the angle bisectors meet now at the same point the altitudes met. Okay. Okay, so let me explain this theorem first, okay? So the people who don't know this. Okay, so this is like angle chasing, okay? So maybe you can see it, but like, can you see like The 90 degrees gives a lot of cyclic quads.
Yeah.
Maybe you want to angle chase this as an exercise while we're doing this. It's a pretty nice result.
Yeah, I'm pretty sure that property proves that that's a straight line.
Mm-hmm.
Like when you draw the line through, right? Like you have like alpha, 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 alpha on all four angles, right? Like where AB intersects at Q.
So we have, this is B,
Oh yeah, BB.
this is A, this is C, yeah?
Yeah, so like BB, because it intersects at Q,
Yeah.
like yeah, just draw like B to B.
Do we know it intersects at Q?
Yeah, it has to, right? Because well, we know BB intersects AC at 90 degrees,
Yeah.
right?
I'm
And we
sure
know
on this
that
one.
B is the altitude of AC.
Yeah, so you're saying this has to be Q prime.
Yeah. So if you draw like
So what do we're making this the orthic triangle, is that what we're saying?
yeah,
Oh, okay.
yeah. So Q prime B and Q prime Q double prime Q prime B are equal, right?
Q prime what? B.
And
Angles, yeah?
yeah.
Yeah, by that property, yeah?
Mm-hmm. And like it's the same on the other side, right? With like Q prime B and Q double prime Q prime B.
Yeah.
Yeah. So like all four of these angles are like the same.
Yeah. Is this another way of proving that they're the same? Because oh no, they're at different places. Oh, okay, so they're the same as, not only the same as these, they're the same as each other, yeah?
Yeah. So all four of them are the same. So that means because Q prime B equals
So that means it's collinear as well, right?
yeah, that's basically what I was trying to
Because you don't need orthic triangle for that to be the reflection, because they're just reflected, yeah?
yeah, but you wouldn't know that like B Q prime B was collinear.
Q prime B. Oh, so, I mean, yeah, if you made this the orthic triangle, right?
Yeah.
That would be on that, because that's the altitude, yeah?
Yeah.
That's the definition. And then the altitude will reflect at the foot of the altitude, so that's fine, yeah?
Mm-hmm.
And then the extra realization from that shows that this is collinear. Huh?
Yeah.
Okay, that's pretty cool. So that's Q. Yeah, so the angles are now equal, right?
Mm-hmm.
This is this dot. It's a vertically opposite makes that collinear.
Yeah.
Nice. Okay, so we know now that if we made it the orthic triangle, we get a straight line.
Mm-hmm.
Yeah?
Yeah, and you know people so like will always be straight.
Yeah. So what does that tell us? It tells us what is it? So if you start with one of the feet of the altitudes, right? Because it seems to like, and so if you started with 2 feet of the altitudes, right?
Mm-hmm.
Then you need the third feet to make it a straight line.
Yeah.
Yeah? It doesn't tell us we should have started with those two in the first place, but if you do start with those two, the third one should be the other one, yeah?
Yeah.
So we still don't know its minimum for all the triangles, yeah?
Mm-hmm.
Because you could have started like here, right?
Oh,
And there might be another way to make it straight. Or maybe there's no way to make it straight from there. But even if it's crooked, it could still be shorter than the straight, could
yeah.
it?
Yeah. So like, what you have to prove at the end, like that Q, so like the last Q is like the same as like B to B prime or something like that. Like shorter or equal to.
Yeah, so that's Sean mentioned it too. So this, yeah, so orthic means it will reflect the straight line. But is it only if and only if, or is it just one possible way, right?
Yeah.
So this was like that pedal triangle thing, I guess. We need like some kind of triangle, some kind of a triangle in center, I guess. No, not even in center because you don't know it's going to be like lined up even. Okay, it says disregarding the 2 points marked C, we observe that the broken line BA. So I think the word broken line is something that's new to me since I looked at these competitions. Like it just actually means like piecewise linear, piecewise straight line. You know,
Yeah.
I thought it meant like dotted line or something, but it means like just, just that's like a broken line. Yeah, straight line segments pieced together. Okay. Um, if you look at BA, yeah. So that's B B A B A B. Oh, it's still missing some APs. Mm. Okay, let's just try to imagine the last one. Um, so what's AB? So that's 6 triangles. So one, two, three. So you do 1, 2, 3, 4, 5, 6 reflections. Is it? Anyway, there's something in the back of my mind that 2 reflections make a rotation.
Oh.
Okay. So this is related to this, I think. So it has angles 2A. What happens here? You have BA. Okay, let's ignore the C's like they were saying, yeah? Focus on this B, A, B, A, yeah? Okay. So it says it goes through an angle 2A, yeah? And then it goes through an angle 2B, yeah?
Yeah.
Okay, which one do we reflect next? You need to get q prime to q to q prime, right? So you reflect this one, yeah? Up here.
You can just use the one on the left.
Yeah. Okay, but I think the argument is something going to be like how much does the angle change, yeah?
Yeah.
Maybe we can start on that. Q to Q prime. Q double prime to Q, yeah? Q double prime. And then you want Q double prime, Q prime to Q double prime. And that's Q prime. And so you reflect that. And then you want Q to Q prime, yeah? Where's Q? Okay, that's the B, okay? We start with an ABC. Q double prime. Q. Okay, anyway, so we're looking at BA. BA. There should be 6 letters, yeah? BA, BA, BA. BA, 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 yeah?
Yeah.
And it goes through an angle of, how does this work? It goes 2A, yeah? And then it goes 2B, yeah? And then it goes like 2A in the other direction, yeah?
Yeah.
And then it goes 2B in the same direction as that 2A, but the opposite direction of that 2B, yeah?
Mm-hmm.
And so the claim is the first BA is parallel to the last BA, yeah? Okay?
The keys is still going to be straight, right?
Oh, this has nothing to do with the cubes. There's only the triangles on the outside.
Yeah.
So this triangle is meant to be sort of congruent. They're all congruent, right?
Yeah.
But now it's even like a translation
Oh. Yeah.
because this is parallel. to the first one, yeah? Does that make sense? And it's the same orientation.
So that's after 6.
Yeah. So it's congruent by translation, and the pairs of corresponding points on these two sides will form a parallelogram. Oh. Okay. So the P and the Q we started with, right?
Mm-hmm.
Will form a parallelogram across this chain, yeah? Okay. And I think Sean's mentioned this in the chat too. So we recall now that the altitudes of angle ABC bisect the angles of its orthic triangle. It follows that after the indicated reflections, the sides of the orthic triangle will, in order, lie on the straight line PP prime. The sides, analogously, the sides of any other triangle, such as the dotted triangle in the figure, will form a broken line reaching from Q to Q prime. Since PQ is equal and parallel to P prime Q prime, the straight line segment QQ prime is equal to PP prime. Okay, let's talk about what P and Q are, yeah? So P and Q. This reflection is Q, yeah?
Mm-hmm.
And if you keep drawing these P prime things, okay, and P double prime, somewhere here. Oh, there's something on that triangle, yeah. Oh, it's on this side of it. And then reflect to P double prime here. It's here as P, right? And then this becomes P. And then that's P, yeah? Yeah?
Mm-hmm.
So our notation's a little bit different. Let's make so when P and Q finish over here, yeah? Mm-hmm. So P becomes here, yeah? And Q, oh, that's weird. P, no, that should be P double prime. P double prime. This is, oh, that's weird. So we end up on the side AB, yeah? It should be P and Q. Well, what happened here? So it's P prime, P double prime, yeah? So there should be P prime here. Okay, that's the. Oh. Yeah, that should be P prime here. That should be P double prime there. P here, P prime here. And this is just P, yeah? And this is P prime. Okay, the P and Q end up here, yeah? Let's call this, like, so those 2 points, let's call like, T of P and T of Q, yeah? The translation. Okay? So the point is that PQ, TP, TQ is a parallelogram, okay?
Yeah.
Okay. So the straight segment is QQ prime, yeah? That's good. We got that right. So this is QTQ for us, yeah? So this is the straight. Let's assume that this is orthic, yeah? Yeah. Okay. Now, so these are parallel, yeah? Okay. Okay, what's the argument here? It uses the fact that any other broken line on the parallelogram is longer than its corresponding straight line, which is equal to P prime. Well, I didn't quite understand that, but okay, so PQ is equal and parallel to P prime Q prime. So that's saying PQ is equal and parallel to T of PQ T of Q, right?
Yeah.
Okay, what does that mean? That means the straight segment QQ prime. Oh. Are we actually drawing the whole straight segment? Oh, that's crazy.
Wow.
Okay, so draw Q to Q prime, right? That's like all this whole big line here, yeah?
Yeah.
It's straight, yeah?
Mm-hmm.
Oh, okay, because it's parallel, you can compare them, yeah?
Oh yeah.
So it's parallel, right? So that means PP prime has got the same length, yeah? So PTP has got the same length, yeah?
Yeah.
So 2 big long lines, yeah? Of equal length.
Mm-hmm.
One of them's straight and the other one isn't, yeah?
Oh yeah.
Okay? So the straight one has the same length as the straight one, but it's crooked, right?
Yeah.
So it's not straight, so it's longer, yeah?
Yeah.
So, oh, that's awesome.
Yeah.
You can compare them. So no matter where you put P, right, it'll give you a longer line than if you took the orthic triangle.
Yeah.
Yeah,
that's like what kind of what I was trying to do. Except
Yeah.
with 3, it doesn't really work because they're not parallel.
It's kind of beautiful. So these kind of things you never really know how they came about, right?
Someone just randomly.
So the guy originally came up with it for calculus, remember?
Oh yeah.
So, like you like romantically, you'd like to visualize someone, just having like really like a big-eyed kind of eureka moment, and then just writing the beautiful proof like immediately, right? But I think realistically, I mean that probably happened for Ramanujan, right? The goddess told him.
Oh yes.
Okay. Realistically, I think it might be like it can happen through calculus, yeah.
Yeah.
Someone bashed it first,
and then
they sought a better understanding of it,
Mm-hmm.
And so this I mean, sometimes you've got a good understanding of it. You're looking for a way of expressing it, but sometimes expressing it in some way contributes to your understanding as well.
Mhm.
So I mean, that's why like sometimes a problem is solved, but people still keep talking about it. The
Yeah.
people looking for the best proof. I mean, Poincaré's conjecture is solved, right?
Mhm.
But that proof is not readable apparently. So you have to kind of simplify it until it's palatable. Like Fermat's last theorem, these things are
Oh
all
yeah.
considered solved, okay? But like,
So,
um, I guess would you have the time to read like 400 pages, where each page is like a condensed 300 pages, kind of, you know?
fun.
And I guess back in the day, you would have to wade through a lot of calculus
Yeah.
to get through this, okay? And so yeah, like, and sometimes people are like, well, if you don't understand the calculus, if you're too dumb to understand calculus, how can you understand this, right?
Yeah.
But maybe it's not that you're too dumb to understand calculus. It's maybe you're you're you're, you're too uninspired to yet be able to come up with this version of the proof. You know.
Yeah.
So I mean, yeah, I mean, this is very nice. This is very nice. If you don't like this, then you don't like mathematics. It's just
Yeah.
maybe not yet anyway. Yeah. Okay. Oh, should I tell you how the angle chase works? Did you figure that out?
You just label each thing.
Yeah. So there's lots of cyclic quads because of 90 degrees. Yeah.
Yeah. So that
So
one.
for example, x is equal to that. Yeah.
Yeah.
Let's call this one like y. Yeah. So x
Oh
is
yeah.
equal to
Yeah.
that because
I
it's
see.
cyclic quad. This is called this is y cyclic quad. Yeah.
Yeah. The
And then
one.
this top angle is 90
Yeah.
minus
Yeah.
y
Yeah.
and it's 90 minus x.
Oh yeah.
Yeah. It's a lot of ways you can do it.
Yeah. Yeah.
Alright, okay, let's finish that one there. This book is really good value.
How much does it cost?